As our second step in the example, let's start doing some computations now. I'm going to do a couple different things. First, we're going to extract some values from the window locations. So basically, we're going to take the family instance location. That's the node that's going to return a list of points indicating where all those different window instances that we selected are. And we're going to be able to pull out the x value and the y value using the point.x and the point.y nodes. Then we're going to use that information. What we'd like to do is basically compute a relative distance from the very first item to the last item so that we can use that to try to create a wave. What we're going to do is basically figure out what that relative distance is and then compute some parameter values, okay, using a wave function. So we're going to do a number of waves, a wave amplitude, and a wave base height. But what we're going to basically do is, based on the location, how far away things are from the first window, okay, we'll then go through and just kind of compute a new value to create a sine wave as we move away from that first window. Okay, so let's take a look at how that's implemented. So here we have all the different model elements, and the first thing I'm going to want to do is basically extract the information from them using the family instance location node. I pull that together, and you can see I have all the different points that are indicating the family instance locations, and I can pull that to an x and a y and get some specific values. So these are the values for the x's. So there's a bunch of values in there, everywhere from -19 going all the way up higher. Now, you can't necessarily count on everything being in strict numeric order because you might have placed these in a different order. So we're going to have to pay a little bit of attention to the order of that list to make sure that we're actually getting things properly. Let me kind of see if I can show you where that is. When I created this wall, I actually placed the last few windows over on the kind of negative side of things, okay, at the end. So I'm going to have to pay attention to that and not just sort of assume that the leftmost one is the least over there, or the has the lowest x value. Okay, so what I'm going to do is basically start thinking about computing a sine wave. And what I'm going to do is basically take those x values, okay, and use those to create some new heights. So what I'll do is just take those x values. I want to see what the minimum is, as well as the maximum. Let's run that so far. You'll see the minimum is -19, the maximum is 28. And what I want to do is basically rescale the x values. I want to basically try to understand where the windows are between that highest and lowest. And the way we're going to go through and do this, there's the min value and the max value, as well as the original value, is we're just going to basically scale all those windows doing something which is very much like creating a parameter. We're just going to basically sort of, using this formula, kind of give them some sort of score between 0 and 1, depending on how far away they are from the furthest one over there, the furthest one to the left. Okay, now what I'll do is take this information and put it into a little bit of a wave curve here. So the numbers that are going to be coming in here are somewhere between 0 and 1, and we'll just use kind of our typical wave function number of waves, wave amplitude and base offset, doing a little bit of sine action in there to go through and compute some new values. Let's go and try that and see how that works. So these are now a bunch of different values that are computed using the sine waves. So everywhere from 7 down to 4, back up to 7. That base offset is 7. So we're kind of using 7 as that kind of like intermediate point for the wave. So you want to get, like we do with most wave functions, make sure that the wave base height versus the amplitude is set such that we never get negative values. Okay. So now we have some beautiful new values that we can go through and use to set those parameters, okay, that'll sort of describe a sine wave. So let's go ahead and think about how we're going to do that in the next step.